Okay, for those of you who came for tutoring, I finally figured out what our mistake was for that last problem. So, and if you didn't come to tutoring, you might want to just watch this anyhow, because it could help you for the test tomorrow. So, this is the information that we were given. And this is cross-section, so perpendicular to the y-axis. So that means it's going to be the area. Boy, I don't know what I'm doing here. Okay. The area of the cross-section dy, because it's perpendicular to the y-axis, and this is going to have to be y equals, and this is going to have to be y equals. Okay, if you look at the picture, I'll just do this on the side. If you have x squared equals 8y, and you divide both sides by 8, you get 1/8 x squared equals y. So this is just a parabola that's a little thinner than a normal parabola, and it should look something like this. And then y equals 4 would look like this. So we're talking about this middle piece in here. Okay, and this is what our mistake was. When you're taking cross sections perpendicular to the y-axis, it's looking like this. So that's the base, and then you have to picture it's like coming out at you. And if it's equilateral, all sides are equal. The thing is that, yeah, it's going to be perpendicular to the y-axis, but it really goes all the way like this. So this is actually the base of a triangle. Or this could be your base. Or this could be your base. Okay, so what's the length of each of these bases? Well, it's going to have to be in the form x equals, because if I have it as y equals and there's something with x's in it, it's not going to go with that dy. So I have to get in the form x equals. So right now I have x squared equals 8y. If I take the square root of both sides, I get x equals radical 8y. But that would only be the piece that's going from here to here. That purple line I just drew. So in order to get the whole long piece, that purple piece plus this blue piece, I have to double it. So the base is actually 2 radical 8y. Okay, so now knowing that, I'm going to erase this picture to make some room. Oh, well, before I erased, you can go back and look at the picture. I know what my y's are. And my y's are going from 0 to 4, based on our picture. Okay, so I need the area of the cross-section. So the area of a triangle is 1/2 base times height. Okay, and this stylus pen really stinks. But I think I packed, oh no, wait, here's one. Sorry. Okay, 1/2 base times height. So the area is 1/2. The base, we just said, is going to be 2 radical 8y. And now we have to find the height. Okay, so let me make some room. Okay. So if you look at an equilateral triangle, if each side is 2 radical 8y, then we know the base, but what we're looking for is this red line, which is the height. So if we create a triangle, okay, I know that this side is 2 radical 8y. I know that this is a right triangle. Because it's an equilateral triangle, every angle is 60 degrees, so this has to be 60. That leaves 30 for this one. Okay, the side across from 30 degrees is half of the hypotenuse. Here's the hypotenuse. Oh my goodness. Things are going crazy. If I divide that by half, I just get radical 8y. The side across from the 60 degrees is radical 3 times the side across from the 30 degrees, which is radical 8y. So if you multiply that, you get radical 24y. So that actually is my height. So now I can go back. It's over here where I was looking for the area. So I have 1/2, and I have my base, and now my height is radical 24y. Okay, now I'm ready to just multiply. So let's make some room. Okay, so my area is 1/2. Then I have a 2. And then I'm going to create one big radical. So 24 times 8, we'll pretend we don't have a calculator, is 192 y squared. Okay? So the 1/2 and the 2 cancel, and I forgot this 2 here. And now I'm just left with radical 192y squared. But I can break that up into radical 192 and radical y squared. And when you square a square root, you just get what's inside. So you get 192, I don't know what kind of radical that is, and y. Okay, so 192 can be broken up into 2 radicals. One of them is 3, and the other one is 64. But the square root of 64 is 8, so you get 8 radical 3y. That's my area. Okay, so now I can go back. And I can substitute everything into my integral. Okay, so I have the integral from 0 to 4. The area is 8 radical 3y, and it's all dy. So I'm going to use that rule that allows me to pull the constant out. And I'm just left with y. Okay, so I'm going to get 8 radical 3. Boy, I was blaming my stylus, but there must be something going on with my iPad. Okay, and now the antiderivative of y is just y squared over 2 as it goes from 0 to 4. So if I put 4 in there, I get 4 squared, which is 16. 16 over 2 is 8. And that gives me 64 radical 3, and that was the answer.